The concept of generating electricity goes back to the basic atomic model, which states that we have protons and neutrons in the nucleus with electrons orbiting around it. These electrons are what carry electricity, or they are electricity itself because they carry a negative charge. So, to generate electricity, all we need is a small amount of energy to pull an electron out of the atom's outermost orbit. From here comes the difference between materials and their ability to conduct electricity. In some materials, it is easy to remove this electron, so they are good conductors. In other materials, it is very difficult to pull the electron from the outermost orbit, or it requires a very high amount of energy, so they are considered poor conductors. One of the most famous conductors is copper. Why is it considered one of the best conductors? Because the copper atom easily loses the electron in its outermost orbit, so we only need a small amount of energy to release that electron from its orbit. This energy can be thermal, chemical, like in batteries, or through magnetic induction, as we will see in the upcoming lessons. One final important point: the real physical direction of electricity is from negative to positive, following the motion of electrons. However, in calculations and engineering, we agreed to take the direction from positive to negative, the opposite direction. This is because scientists discovered the true direction very late, but they noticed that the calculations were correct from the beginning, even when the assumed direction was opposite. So they continued using the convention that current flows from positive to negative in calculations. Also, to make the concept feel more natural, just as water flows from a higher level to a lower level, electric current is considered to flow from higher voltage to lower voltage. But if we go deeper from a physical perspective, we must remember that electrons actually move from negative to positive.